Hello, hello again, another Dragon Color reaction. Today we will be watching why SpaceX and NASA rockets are so different. I guess because NASA haven't really... Let's see, let's just watch because I don't want to guess and then be guessing wrong. Because I think that maybe it's because of progress. The SpaceX rockets are probably much younger, let's say, and the NASA haven't really did their own rockets. I'm not sure now because I was just thinking that maybe they haven't really done it in their own rockets in a long time because they're outsourcing to companies. Well, let's just watch. Let's see. Let's learn.
Let's start by acknowledging something crucial. Although NASA and SpaceX are both at the forefront of space travel, their rockets look entirely different. And that's mainly due to the fact that they have very different goals. Imagine packing for a trip to the edge of the solar system. This is the kind of durability NASA is...
Okay, I'm gonna retract what I said about NASA because I keep forgetting that they do make their own rockets for like satellite and all the probes that are going out into deep solar system and stuff like that. So that can't be it. I was thinking more about rockets that they're actually getting people out. So that's not
thinking about. They need materials tough enough to withstand the unknown. That's why NASA relies on advanced materials like aluminum-lithium alloy, known for being both lightweight and incredibly strong. This allows their Space Launch System, SLS, to survive the intense forces of a rocket launch and the hostile environment of deep space. Meanwhile, SpaceX isn't playing that same long game. They're taking a completely different approach. Instead of one-time use rockets like NASA's, they are laser focused on getting rockets to fly multiple times without starting from scratch. Their Starship, made from stainless steel, can handle extreme heat, especially during re-entry. That's why you'll often hear Elon Musk comparing space travel to airplanes. Think of it like your car. You wouldn't drive it once and then throw it away, right? You don't throw away a plane after one trip, you fly it again. With Starship, the goal is to reduce the cost of launching into space by using the same hardware over and over. And that's not all. NASA's SLS uses heat shields that burn away during re-entry, like peeling off a layer of skin each time it comes back to Earth. SpaceX's Starship? It uses heat-resistant ceramic tiles that stay intact, giving the spacecraft multiple chances to prove itself. This isn't just a difference in materials. It's a completely different design philosophy. But what makes SpaceX so obsessed with getting more bang for your buck, while NASA sticks to more traditional designs? The answer lies in how they both operate, and of course, where they get their money. Now, you may ask, how does the funding for a government agency like NASA differ from a private company like SpaceX? Well, here's a question for you. What if your entire business model was based on never running out of money? Think of NASA as the slow and steady marathon runner. Its funding comes from the US government, which gives them a steady stream of resources, allowing NASA to pursue ambitious long-term projects like sending humans to and from the moon or even to Mars. But the trade-off? NASA has to align with government priorities and justify its spending to taxpayers, which can make their process slower and more political. But here's the thing. That level of funding allows NASA to dream big without worrying too much about immediate profits. It's like having a safety net that lets you try and try again without the fear of losing balance and falling off. It allows them to invest in groundbreaking technology and conduct extensive research, ultimately paving the way for future generations of explorers. On the other hand, SpaceX is more like a high-speed sprinter, constantly racing to innovate and stay ahead. As a private company, they don't have the luxury of guaranteed funding. Every launch and new contract has to bring in enough money to keep the lights on. So while NASA can afford to play the long game, SpaceX has to be scrappy and efficient. They need to keep their costs low and find ways to make their rockets cheaper to build and fly, which is where the reusability comes in. Using the same rocket multiple times isn't just a neat trick, it's a necessity. SpaceX's financial model depends on this to stay competitive, which has now become a constant pressure to innovate and has forced them to do things differently. This drive for efficiency also extends their launch schedules, allowing SpaceX to conduct frequent missions, a flexibility that NASA sometimes lacks due to the politics involved. But how does that impact their rocket engines, the heart of any space mission? Have you ever heard of NASA's Saturn V rocket? You know, the one that took astronauts to the moon? That rocket had just 5 engines. Those
the size
F1
of them, though.
engines were massive, each one powerful enough to lift a skyscraper. But once the job was done, they were discarded. A one-time deal. Now, compare that to SpaceX's Super Heavy rocket, which has 33 engines. Why so many? Well, it's not only about raw power. Each individual Raptor engine is smaller and less powerful than the F1 engines that NASA used, and generates only a third of the power required to achieve the necessary total thrust. So multiple engines are needed. Also, with that many smaller engines, SpaceX can afford to lose 1 or 2 during launch and still make it into space. It's like having a fleet of backup generators. If one fails, no problem. The others can just pick up the slack. This gives SpaceX more flexibility and control during launch and landing, which is crucial for their focus on efficiency. Each engine is designed to be fired multiple times, making Super Heavy the ultimate multi-use rocket booster. This engineering allows SpaceX to rapidly test and create new technologies each time. But NASA must have seen how successful SpaceX is, spending less and getting more. Why does it insist on sticking to larger, more powerful engines? Is it mainly because NASA's missions prioritize power and reliability, especially for deep space? They are thinking about sending humans to distant planets, not just getting them into orbit. The Saturn V engines, while single-use, provided unmatched power and reliability for that era.
I mean, yeah, I actually don't know what to say about it, because kind of explaining why. Obviously, NASA have to explain to the taxpayers what they're doing. I think it might be to do with the fact that basically they need to rely on something they know gonna work. Like the SpaceX, it's doing the research while they're testing everything. So obviously NASA can't really go with that, I think. I don't know. We'll see. And this is a long ad, so I'll see you in a moment. Bye. And I'm back. And like I was saying, I was kind of thinking about during the ad that it must be something to do with the fact that NASA knows that they can rely on those. And SpaceX is just basically doing research while they working on it. Maybe that's the
SpaceX,
answer?
on the other hand, needs the flexibility for frequent launches and landings.
Yeah.
This is where the differences in their philosophy about how space exploration should be done shine. So now that we know how their engines differ, let's have a deeper look at the most vital difference between both organizations' goals, which are reusability versus single use. NASA's older rockets, like the Saturn V, were built for single use. After getting to space, their parts were discarded, like an expensive one-way ticket. But NASA wasn't entirely stuck in this model. They did experiment with reusability through the Space Shuttle program. The shuttle's orbiter and solid rocket boosters were designed to be reused, unlike the massive external fuel tank, which was discarded and lost after each flight. But here's where things get tricky. While the Space Shuttle was groundbreaking in its attempts, it wasn't as cost-effective as NASA had hoped. High costs of refurbishing the shuttle after each flight, combined with the tragedies of Challenger in 1986 and Columbia in 2003, led to the program's retirement in 2011. NASA had ventured into the world of reusable spacecraft, but found the execution far more difficult than anticipated. On the flip side, SpaceX has been all in on reusability since day one. Their Falcon 9 and Starship rockets were built with the specific goal of flying multiple missions. Like Elon said,
you can imagine that if planes were not reusable, very few people would fly.
This mentality allows SpaceX to launch more frequently and at a lower cost, appealing to commercial customers eager to cut expenses. Now, it's interesting to note that NASA is starting to adopt some of these ideas, working with SpaceX on reusable technologies for future crewed missions. This collaboration could mark a significant shift in how both organizations approach rocket design, potentially combining NASA's reliability with SpaceX's innovative spirit. But what's intriguing is that SpaceX's approach to design is influenced by more than just economics. There's yet another factor that just might surprise you, and that, believe it or not, is pop culture.
Is it?
Elon Musk admitted that part of their design for SpaceX's rocket was inspired by a comedy movie. Yes, you heard that right. Specifically the scene from The Dictator, 2012, where the dictator critiques his engineer's missile design, prompting Musk to consider making SpaceX's rockets more aesthetically pleasing. This playful attitude speaks to something bigger. They aren't afraid to take risks and challenge norms, even if it means drawing information from unexpected sources. This is a huge contrast to NASA's more traditional, no-nonsense approach. While NASA follows tried-and-true methods to ensure the safety of their missions, SpaceX is more willing to experiment and push boundaries. But both approaches have their place in the evolving world of space exploration, and each have led to breakthroughs that have significantly reduced the cost of access to space. NASA's legacy of meticulous engineering and SpaceX's daring designs can encourage rapid progress of us humans in general, and as they learn from each other, the potential for collaboration grows. But let us not mistake collaboration with one being better than the other. In this world, they can equally thrive in their differences. NASA's goal is clear: long-term missions, deep space exploration, and the technology to survive the unknown. Their Artemis program aims to establish a lasting human presence on the moon, preparing us for the distant planets beyond. SpaceX, on the other hand, is racing to make space travel more accessible to everyone, not just astronauts. Two paths, two visions, both driving the future of space. But will they compete? Or will they collaborate to reach the stars? Either way, buckle up because the race is only just beginning. Bye for now.
That was good. I did explain it a different way of thinking in there. So I'm not sure if I actually understood fully. But like he said, NASA's going into more long term. And the thing is as well, it's publicly funded as well. While the SpaceX, it's a private company. They're working together. Eventually they're gonna... I don't know what to add. So yeah. Thank you very much for watching and I see you tomorrow. Bye!